In April 2026, 4 astronauts flew further from Earth than any human being has in over 50 years. They went behind the moon, to the dark side, the side no human eye has ever seen in person. And when they came back, NASA held a press conference, talked about science, talked about exploration, talked about humanity's next chapter. What they didn't talk about? Why this is actually happening. Because here's the thing. We've been to the moon before. 12 astronauts walked on it between 1969 and 1972. Then we stopped. For over half a century, we didn't go back. So, why now? Well, the official answer is exploration, curiosity, the spirit of discovery. But that's not the real answer. The real answer involves trillion-dollar resources sitting on the lunar surface, a quiet war being fought between the world's most powerful nations, and a resource so valuable it could solve Earth's energy crisis for the next 10,000 years. Stay with me, because this goes deeper than you think. The official story versus the real story. NASA calls it the Artemis program. The stated goal? Return humans to the moon, establish a permanent base, and use it as a stepping stone to eventually reach Mars. And look, that's real. That's genuinely happening. Artemis 2 just proved we can get there and back safely. But stepping stone to Mars is the version of this story designed for press releases. Here's what's also true. China has its own lunar program, the Chang'e missions, and they are moving fast. In 2020, they brought back lunar samples. In 2024, they landed on the far side of the moon, something no country had ever done. They have publicly stated their intention to establish a permanent lunar base by the 2030s. Russia is partnering with them, and the target? The place both programs are racing toward is the exact same place NASA is heading. The moon's South Pole. Now that's not a coincidence. That's a competition. The question is, what's at the South Pole that everyone wants so badly? Water ice and the economy of space. Here's something most people don't know. The moon's South Pole sits in permanent shadow. Craters so deep that sunlight hasn't touched their floors in billions of years. And in those craters, locked in the frozen dark, there is water ice. Confirmed. Real. Enormous quantities of it. Now, why does that matter? Well, water in space is not just drinking water. Water is rocket fuel. Split water into hydrogen and oxygen, and you have the two components of the most efficient rocket propellant known to science. The same combination that powered the space shuttle's main engines. So what this means is that if you can mine water ice on the moon, you can manufacture rocket fuel on the moon. And if you do that, suddenly the moon isn't just a destination, it's a petrol station, a launch pad, a refueling stop for the entire solar system. The cost of sending missions to Mars, to the asteroid belt, to the outer planets, it collapses because you're not dragging all that fuel up from Earth's gravity well anymore. Whoever controls the lunar South Pole controls the economics of space exploration for the next century. That's why everyone is racing there. But water ice isn't even the most valuable thing up there. Helium-3 and the energy prize. This is the part that most space videos skip over, because it sounds like science fiction. Well, it isn't. The moon's surface contains something called helium-3. It's a rare isotope, incredibly scarce on Earth, where our atmosphere and magnetic field block it. But the moon has no atmosphere. For billions of years, it's been sitting in the direct path of the solar wind, absorbing helium-3 directly into its soil. Estimates suggest the moon holds around 1 million tons of it. So, what's it used for? Well, helium-3 is the ideal fuel for nuclear fusion, the process that powers the sun. And unlike conventional nuclear fission, fusion using helium-3 produces almost no radioactive waste. It's clean, efficient, staggering in its energy output. 25 tons of helium-3 could power the entire United States for a year. And at current projections, a single space shuttle cargo bay's worth, around 40 tons, would be worth approximately $5 trillion on Earth. The entire moon's reserves? Enough to power human civilization for tens of thousands of years. Now, we don't have fusion reactors ready to use it yet, but we're getting close. Closer than most people realize. And the nations that establish mining rights on the moon now will be the nations that control that resource when the technology catches up. That's not exploration, that's geopolitics. The legal Wild West. Now here's where it gets really interesting. Who owns the moon? The short answer? Nobody and everybody. The Outer Space Treaty of 1967 says no nation can claim sovereignty over the moon. You can't plant a flag and say, this is ours. But, and this is critical, it says nothing about resources. So in 2015, the United States passed the Commercial Space Launch Competitiveness Act. It essentially said American companies can go to space, extract resources, and own what they take. Luxembourg passed similar legislation, the UAE, Japan. China and Russia, notably, did not sign the Artemis Accords, the US-led agreement that sets out rules for responsible lunar exploration. They're building their own framework. What this means in practice, there is no agreed international law governing who can mine what on the moon, no enforcement mechanism, no referee. Whoever gets there first, establishes a base, and starts extracting resources, they hold the advantage. Not legally, practically. It's the same dynamic as the early age of exploration on Earth, when European powers raced to plant flags on continents. Except this time, the prize isn't land. It's energy, infrastructure, the commanding heights of the solar economy. And the clock is ticking. What Artemis is actually building. So when NASA talks about Artemis, the Gateway space station orbiting the moon, the lunar base camp at the South Pole, the long-duration surface missions, what are they actually describing? They're describing infrastructure. The Gateway isn't just a science lab, it's a starting point. A permanent human presence in lunar orbit that can support missions to the surface, to deep space, and eventually to Mars. You see, the South Pole Base isn't just a research outpost. It's positioned directly where the water ice is, where the permanently shadowed craters are, where the resource extraction begins. And Artemis isn't just a NASA program. 37 countries have signed the Artemis Accords. SpaceX is building the human landing system, the vehicle that will actually put boots on the surface. Commercial companies are lined up to build rovers, mining equipment, and habitats. This is not the Apollo program, a government sprint driven by Cold War pride. This is the beginning of a permanent, commercial, multinational presence on another world. The science is real. The exploration is real. But underneath it all, the foundation is economic, political, strategic. We are not going back to the moon to plant a flag. We are going back to the moon to stay. What happens next? So here's where we are. Artemis 2 has flown. Humans have orbited the moon for the first time since 1972. The next mission, Artemis 3, is targeting an actual landing at the lunar South Pole, the first crewed moon landing in over 50 years. China's program is targeting a crewed landing by 2030. Both are aiming at the same craters, the same ice deposits, the same ground. There is currently no international agreement on what happens when two nations want to mine the same crater. No treaty, no mechanism for dispute resolution. The optimistic version of this story: the race to the moon drives unprecedented technological progress, makes clean fusion energy possible, and eventually leads to some framework for shared governance of space resources. The less optimistic version: the moon becomes the first extraterrestrial flashpoint in a new era of great power competition. Not war, but a scramble, a land grab in slow motion, playing out over decades, with consequences that shape the next century of human civilization. Either way, it's already started. And most people watching the news coverage of astronauts waving from a capsule have no idea. Here's what we actually know. We are returning to the moon because it contains resources of almost unimaginable strategic value, because two major geopolitical blocs are in direct competition for those resources, and because the legal framework governing who can claim what doesn't yet exist. The science is real, the exploration is real, but the engine driving all of it, the reason the money is flowing, the reason 37 nations have signed accords, the reason SpaceX is building a lunar lander, is power, resources, the future. The moon isn't a destination anymore, it's the opening move. And we are only just beginning to understand what game is actually being played. If this is the kind of video that makes you think, subscribe. There's a lot more of this coming.